Okay, so let's look at the first problems on our midterm review. So number 1, a box contains 10 red marbles, 10 blue marbles, and 10 green marbles. 2 marbles are drawn with replacement. The first thing we want to do is list the sample space. Alright, so we're going to draw 2 marbles. So let's just think of what we could get if we draw 2 marbles. We could have 2 red marbles. We could have 2 blue marbles. And we could have 2 green marbles. Alright, we could have a red and then a blue marble. Or we could have a blue marble and then a red marble. We could have a red and then a green marble. Or a green and then a red marble. We can also have, let's see, that's everything with red. So we could have a blue and a green marble. Or a green and a blue marble. And there are all of our choices. Okay, so that's our sample space. Now, let's find the probability that at least one marble is green. Well, all we need to do is look at our sample space and see how many of these outcomes have at least one green marble. So if we take a look, green is at least one green marble, so there's 1. Red-green is at least 1 green marble, so that's 2, 3, 4, and 5. So 5 of them have at least 1 green marble, and there are 8 possible choices here out of the entire sample space, so this is 5 out of 8. So in part C, we want to find the probability of drawing a green and a red marble. Well, there's 2 possibilities that have a green and a red marble together. We have RG and GR. Now, if it had said a green and then a red marble, we'd only be looking at green, red. But we can have RG or green, red. So both of those satisfy our condition. So that's 2 out of 8 or a 4th. All right, so let's go to 2. A sample space is given. Let's notice it's composed of the 6 letters A through F. Event A is composed of A, B, and D. Event B is composed of C, D, and F. We want to suppose that the probability of A is 0.3. The probability of both B and C, that's each one separately, is 0.1. And the probability of D is 0.05. And the probability of E is 0.05. So we want to determine the probability of F. Now remember that the probabilities in a sample space have to add up to 1. So all we need to do to figure out the probability of F is to subtract all the probabilities we have from 1. So we want to subtract off 0.3, 0.1, 0.1, 0.05, and 0.05. And if we do that, oops, there should be a subtraction sign and not an equal sign. If we subtract all of those, we are going to get that the probability of F is 0.4. All right, so now the probability of A. Well, to get the probability of A, we're just going to add up the probability of all of its separate outcomes. So let's notice that A is composed of A, B, and D. So we want to add up the probability of A, the probability of B, which was 0.1, and the probability of D, which is 0.05. And we will get 0.045 as our probability. I'm sorry, 0.45 is our probability of A. Now let's do the same thing for the event B. So we need to add up C, D, and F's probabilities. Well, probability of C was 0.1, D was 0.05, and F, as we found out earlier, was 0.4, and this is going to give us 0.55. All right, so let's look at number 3. The following two-way contingency table gives a breakdown of the student population at a certain college according to year in school and major. A person is selected at random. We want to find the 3 probabilities that are listed below. All right, so the first one is we want to find the probability that the person is a freshman. Okay, so let's look at all of our freshmen. we have STEM majors who are freshmen, and we have non-STEM majors who are freshmen. We simply need to add together those two probabilities for freshmen, and that's going to give us 0.05 plus 0.2 and 0.25. All right. Well, now let's find the probability that someone is a STEM major. Notice STEM major is this column right here. We just need to add together every single probability in that column. All right, so if we do that, that's 0.05 plus 0.03 plus 0.01 plus 0.01. And let's see, I believe that's just going to give us 0.10. All right, now let's go to C. The person is a freshman STEM major. Now let's notice our freshmen are in the first row. Our STEM majors are in the first column. We want both of these things occurring at the same time, which will be our freshman STEM majors, only this entry right here, 0.05. All right, let's go to number 4. A sample space for 3 coin tosses is S equals, and there's all of our possibilities if we toss a coin 3 times, with HHH representing head, 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 and HHT represent head, head, tail, and so on. So we want to define 2 events as E, at least 1 tail is observed, and F, more tails than heads are observed. So the very first thing it asks us to do is list the outcomes of E and F. So let's start with E. So E is going to be at least 1 tail is observed. So let's notice in our sample space, HHH does not contain any tails, so it certainly is not in E. At least 1 tail, well, HHT would have at least 1 tail, as would HTH, as would THH, as would TTH, that's at least 1. This is at least 1. HTT is at least 1 head, or tail rather, and TTT is at least 1 tail. So it's everything but the HHH. Well, let's look at F. F, we want to find the event that more tails than heads are observed. Okay, so we need more tails than heads. Well, so certainly anything that has 2 tails is going to have more tails than heads. So there's those 3. And then really tails, tails, tails has more heads than tails. Has 3 more tails than it has heads. All right, so there's F. All right, so now it says list the outcomes of E intersect F, E union F, and E complement. All right, so let's start with E intersect F. Oops, I don't know why it did that. All right, so let me move this over because for some reason that thing has jumped on me. All right, E intersect F. And I'll have to get my funny little symbol and insert it here for intersect. Recall that E intersect F is what they have in common. So if we look up here at E and F, at the combinations or the outcomes that they have in common, they really have in common everything in F. So this is everything that's in F. They both have TTH, they both have THT, they both have HTT, and they both have TTT. So E intersect F in this instance is actually F. All right, well, let's get E union F. E union F means we're going to combine the elements of both groups. If we put them together, now remember, we don't repeat anything. We just have those same elements in 2 groups. We just put them in there once. So if we combine them, they're actually going to be equal to E. Because everything that is in F is also in E. And course, E has more. All right, so now let's look at E complement. Get it out of the subscript or superscript there. All right, now remember that a complement is everything that is in the sample space that is not in E. So if we look at E and we look at our sample space, the only thing in this sample space that's not in E is HHH. So the complement is HHH. All right, so assuming all outcomes are equally likely, we now want to find the probability of each of these events that we just listed in B. Well, that's fairly easy to do now that we know how many items or outcomes are in each event. So if we want the probability of E intersect F, and I'm just going to go up here and put it beside this. Oops. E intersect Well, let's notice there were 4 outcomes in E intersect F out of the total up here of 8 outcomes. So that's 4 out of 8, or 1/2. Now we can do exactly the same thing for our probability. Let me put a comma there just so those aren't running together. Let's do the same thing for our probability of E union F. There are 1, 2, 3, 4, 5, 6, 7 outcomes in here out of 8 total in the sample space. So this is 7 out of 8. And then last of all, our probability of the complement. Well, we've only got 1 outcome in the complement out of our total sample space of 8. So that is 1 out of 8. All right, so we've answered C. Now, question D. Move this up. Determine if E complement and F are mutually exclusive. Explain why or why not. Now, remember, 2 events are mutually exclusive if they have an empty intersection or if they have nothing in common. All right, so if we glance at E complement, it's composed of HHH. And if we glance at F, it's composed of outcomes that are not the same. So these two have nothing in common. All right, so E complement and F are mutually exclusive because they have no outcomes in common. Or you could write, if we intersect them, that intersection is empty. All right, so now let's look at 5. A deck of cards is composed of 20 cards with 5 cards from each of the colors red, green, blue, and purple. Actually, I'm going to stop here. I just realized looking at this, I'm going to run out of time for number 5. So we'll save number 5 for the next video.